Well, hi, good morning. Thank you so much for joining me here. Today is November 4th. Yesterday I had some what I think is pretty good success figuring out about this mysterious missing capacitor. This has been, I saw this right off the bat when I started working on this radio. This capacitor has been disconnected. So, what's the story behind that? I've left that sorting out till now while I do other work on the radio. And what I'm left with now is just one more of these. So yesterday I sorted one out, now for the other one. And my guess is it's just not installed. Whoever disconnected this just did away with it. We will see. So the thing to do, I think, is to start with the layout diagram, even though I know that's got problems with it, but let's start there, and the schematic, then we'll start looking around inside the radio. Okay, we'll start with the layout diagram here. This is the capacitor I'm chasing down. Now, yesterday, what was it I actually sorted out? Which one was it? It's this one here. So this line, I installed a 4 microfarad capacitor on it. So that takes care of this one. Now, that leaves this one here. And this one appears to be connected in one direction this way through a resistor. I sort of looked at this already. We will look again. And this one is connected here. That's right. This doesn't make sense, does it? And that led us to this thing. And then that led to more confusion about the whole deal. Right. So if we decide that this is not the radio I've got, because this doesn't exist, this terminal board is never installed there. We come up here to the schematic and we try the same thing from here. I believe the schematic fits the radio better, if not completely. So this is the one I found yesterday and installed. Now we're after this one. I think I remember tracing it back and then something happening here. I don't know what. This wire doesn't exist. To here. Okay, let's start from here again. We'll follow this to that coil, and we'll find the L6 and find this capacitor again, and then from the capacitor end we will try to find this resistor. L6. Okay, here we go. Kind of retracing some of the steps I've taken a couple times, but with a lot of this stuff, and just a lot of things in life generally, it's an iterative process. You have to come at it again and again and again to finally fit it all together. So I've already lost track of what I'm doing. I gotta have the diagram sitting right here on the screen. So I'm gonna set that up so we have the diagram showing, and carry on from there. Okay, starting kind of from scratch here. So I'm going to identify what the pin number is for this grid here, which is coming down and reaching the capacitor. So which grid is that? That's grid number 2 in the 6A7. I have my book already open here. 6A7, grid number 2, G2 is pin 4 on a 6A7. So we find pin 4 on the tube and trace back. Pin 4, right? getting a bad feeling about this already. Pin 4. So here's pin 1, 2, 3. Here's 4. Okay, 4 has a single wire on it, and it comes to this terminal on the coil. That's exactly what this schematic shows. So I got my finger on L6. Now I want to find the other half of L6. It has a resistor and capacitor on it. Well, right here is another pin with a resistor and a capacitor on it. Another terminal. The capacitor goes around to another pin on the coil. The capacitor goes around, follows this wire to another pin on the coil. Okay, so this is working out pretty good. The resistor value is 2200 ohms, but I don't think that's 2200. Didn't I measure this? Body end dot, so orange, so it starts with a 3. So I don't know how to get 2200. There's a 3 here. Looks more like 30,000. We'll have to measure this. Okay. This resistor, by the way, is going from this connection down to here. If we assume that's where the 2200 is, that this is actually the 2200 position resistor, we come to here. We should be off this terminal encountering the capacitor, and there is a wire. There's a wire coming here. It's this wire. It goes to the top of the resistor. Top of the resistor. And that seems totally different. So we've kind of got to here and are encountering a connection to the top of this. Well, if you move this wire, if you rather than connect it here, if you connected it over here, you'd be at the top of the resistor. You'd be at the top of the resistor. Then you would have abandoned this. This would disable this filter to some degree, not having this resistor. The idea is the electricity looks at this 30,000 ohm resistor and goes, no way, I'm going this way. That's what the signal would do. If you don't have this resistor here, well, that's interesting. You don't have this resistor here, but you've connected it over here. So you have this little bit of resistance. 1300 ohms here. I don't know what to make of any of that. So that's what it looks like's been done, though. It looks like we have a connection here, straight through a fairly large resistor, and then we're up here. So now this on this side, if you're taking power from the power supply on the input side of the pi filter here, you're taking a hummy signal. There'd be a hummy signal here. So you need to filter it more before you use it if you're sending it to a sensitive part of the radio. Sometimes this power will go to the output tube, and the little bit of hum that's here won't matter because the signal in the output tube is overpowering. It's just way louder than the hum. But if you're taking it from here and sending it up into the sensitive parts of the radio, and this is the sensitive part for sure, then you need to filter this really well. So they put an additional filter on it. But in this radio, the signal or the power is tapped off this side of the filter. This is a much more filtered output here. Filtered power supply, if you like. So much less hum. You may not need this or this. So this may be, one of the engineers said, you know what, we can get rid of this. If we just move this wire over here, click our heels twice, stick a different size resistor here, and we're done. And we saved this, the cost of this. Bravo! Bravo! Put something more in that boy's envelope next week. That could be what's happened here. They just figured out a cheaper way of doing it satisfactorily. Okay, so if that's the case, then what about the 4? Well, wait a minute. The 4 is in the radio. The 4 is in the radio. Just disconnect it. So what would you do with the 4 now if you wanted to connect it? Oh, well, what was done down here? What did they do down here? So they brought the 4 in here. Wait a minute now. This is just yeah. my brain kind of melted down looking at that. Every time I look at this diagram, I go, yeah. So we got 3,000, and then straight to the power supply. Well, I don't know about 3,000. We have an orange resistor here, but it doesn't go here. Oh, I can't look at this. This is just I have the radio, I have the schematic, I have that other diagram we just looked at, and then I got a thing in my head. All 4 of these things going on. Well, the question would be, do we need to do this? Do we need to add this? Now, the radio does have a hum in it. So if I were to add it, actually, maybe a better question is, if I were to add some capacitance here for filtering purposes, where would I add it? It's already sitting on an 8, right? We're thinking this wire comes down and hooks up here. So it's already got an 8. And if I boost this up, I'm be putting a fair bit of capacitance on the other side of this coil. May not be the smartest move. If you introduce a resistor here and make this filter, like, well, wait a minute. Wait a minute. The capacitor was in there going somewhere. What would have to have happened is more rewiring took place in the radio, and the story about this wire in a later model doesn't make sense, because this is here in this radio. So they were doing something with it. I can't figure it out by looking at the other diagram, and this one's, how big is that resistor? So basically all the way through here you'd have 2,000, you'd have basically 30,000 ohms, which would be the I guess you would call that the plate resistor, even though it's not on a plate, it's on a grid that's acting as a plate. Let me measure that resistance. I keep forgetting you've got the camera view here at the same time. Let's measure the resistance of this guy. Is it 30,000? Or in that ballpark? Okay, measuring it in the circuit. 35,000. 35K. So here's the 30 that's needed to offset the operation of the tube. I stick a big filter in on the tube side of things. If I try to stick a filter in here, all I'm really doing is adding more, stick a capacitor, all I'm doing is adding more capacitance to the filter capacitor. Filter capacitor, I've never done anything about it, he says, suddenly remarking. This guy, I haven't done anything about this guy. Let's deal with this. Regardless of how it's in the circuit, we'll just, it is the way it is. I'm going to replace this. Now this says it's a 20, and on the schematic it shows it as a 10. Let me just check. Forget what I was doing. Let's do this. The 35 is here, a 10. But they have a 20 in there. They have a 20 in there, and this, but I bet you it's not 20. I bet you it's worn out. So I can put a 10, or I can go a little bigger here if I want. It's on the input side. It means upon starting the radio, this has no charge, and the voltage here is 0. And the problem with putting a really big capacitor here is you can cause an excessive voltage in the tube briefly during startup, or a voltage that won't appear there if this is a smaller capacitor, or won't appear there as long, something like that. So I mean, there's a limit to what you can do here. Why am I even talking about this? Oh yeah, C35. Time to go drink coffee, I think. Probably, one thing I could do, I could increase this. I can increase this a bit. Let's deal with this one. See if the hum goes away, and then we'll ponder the situation up this way afterwards. Yeah, let's check this guy out. In fact, let's check him out right now. We're going to get rid of it. We're going to nip off one lead from it here. We're really going to get rid of it. We're going to abandon it in the radio. Now I want to test this with my we'll try this tester on it. Big electrolytic capacitor. I don't know how well this tester works here. So what did it say? It says what? It says what? I don't know what that is. That's not. It's got a 0 NF. Oh, it's 0.0. 113.0 nanofarads. So it's 0.1. This is showing this to be a 0.1 capacitor, but it's actually 20. Wow. Wow, V loss 19%. That's a big number. I think that, trying to interpret the results of an instrument that thinks it's testing a perfectly good quality capacitor, I'm sure that's a dud. Aim for a 15. Why don't we aim for a 15 in there? Why not? Okay. I'm going to stick a 15 in there. Okay, even though every time I look at the schematic or one of those diagrams and look at the radio, I think I just don't have a grip on things here. I think we're going to test the radio. I've put the capacitor here. It's 2 in parallel to get 13. So it's a 13 here. Pretty much the same at the other end of the power supply. It's up here. Okay, never mind. Antenna's connected. I think it's still switched on from yesterday. Negative is connected to the chassis. There we go. Okay. Now, what about that hum? Don't hear any hum. How do you like that? That got rid of the hum.
$197 on average.
Now, one problem here is that some of us are still paying for last year's travel.
That is true. We found that about a quarter of people who charged last year's holiday travel expenses for their credit card still have not paid them off. So those people are...
Yeah, I think everybody in the world is struggling now and using credit to try to get through the financial change that we're all being subjected to. Here in Canada, our interest rates have gone up. I think it's the same in most countries in the world. And for those of us who have variable rate loans or mortgages, the situation is critical, and it's tough. Tough here in this household, that's for sure. Okay. Now we're running this with only 89 volts. Mind you, they're good volts. They're really good volts, but let's give it even more good volts here. A little more volume.
Automatically booking Airbnbs for their accommodations over the last several years.
Sound is good.
Cool new option. It would have...
Volume is plenty.
The Airbnb, the extra charges people are having to pay.
Let's try a little shortwave now. Okay, we're on the shortwave band. Here, look at the dial. On the shortwave band. So we're looking down here at the bottom. We're tuned around 3. I'm not going to hear much around 3, I don't think. Won't hear much on this radio during the day. Maybe up at the very top here. No. Ooh. Pointer that doesn't seem to stop in the right place. It should be stopping about there, shouldn't it? I don't know. Don't know yet. Look, there's a little world map on there. I never noticed before. The pointer's coming out of the North Pole. Yeah, there's nothing down here to pick up, certainly at this time of day anyway. Okay. Yeah, this isn't the greatest shortwave band. This is an evening shortwave band. Maybe in this area here. And the rest of it, not really. Okay. Good. What to do next? Well, I think I'm going to give up the hunt for the other 0.4. I think it's immaterial. I don't think it matters. So what exactly this was doing up here, who knows? But the radio's not humming. Everything is working. Voltages are right. We're golden at this point. All that remains is a little bit of alignment work, which I think I'll take on tomorrow. So because the radio's working well, it probably doesn't require much attention in the alignment category either. So that's great. But I think that's it for me today. Very good. Got rid of the hum finally. Could have done that capacitor a long time ago. I just kept kind of going by it and overlooking it, and not actually dealing with it until now. But it's good. Very good. Very happy. Thanks a lot for watching, and tomorrow we'll align the radio, and I think we'll be done. See ya.